Good afternoon, everyone. My name is Braden McDonald, and today I will be discussing my PhD project, which is looking at the stratigraphy, detrital zircon geochronology, and provenance analysis of the Paleoproterozoic Belcher Group located in Nunavut, Canada. Atmospheric oxygen, although abundant today, was essentially non-existent during the early stages of our planet's history, with many estimates placing atmospheric oxygen levels well below 10 to the 6 of present atmospheric levels. As such, oxidative weathering processes were not operating at the time, and this is reflected by the sedimentary rock record for the Archean through low concentrations of redox-sensitive elements, a small seawater sulfate reservoir, and by the presence of banded iron formations, which are only able to develop when iron 2 accumulates in oxygen-free water columns. But in addition to this, we see the presence of mass-independently fractionated sulfur isotopes within the rock record. Now, there is some evidence that suggests possible whiffs of oxygen existed during the Archean, but these have been linked to the advent of oxygenic photosynthesis. However, the exact timing of these are still debated. That said, it was not until the Paleoproterozoic did the atmosphere see appreciable growth in O2 concentrations during the Great Oxidation Event. Multiple lines of evidence, including redox-sensitive element accumulation, loss of banded iron formations, and the expansion of seawater sulfate reservoir, point towards overall oxygenation. But it's the loss of the sulfur MIF signature that carries the most weight. As a result of the GOE and increased delivery of bioessential elements to the oceans, seawater chemistry became more conducive to widespread primary productivity. This resulted in an increased delivery of organic carbon to the seafloor and ultimately in a massive carbon isotope excursion known as the Loma-Gundy. While initial estimates following the Loma-Gundy suggested atmospheric oxygen remained high, trace element compilations and studies suggest the following period was actually characterized by a loss of atmospheric oxygen. Sedimentary uranium and molybdenum compilations both show a decrease in concentrations following the Loma-Gundy, while sulfur, carbon, and oxygen isotope studies suggest that during the waning stages of the Loma-Gundy, that atmosphere was starting to experience a deoxygenation event. However, a large part to understanding what exactly happened immediately after the Loma-Gundy during this DOE is our ability to find samples from that period that are easily accessed and relatively unaltered. The Belcher Group in the similarly named Belcher Islands of Nunavut offers us this chance. The Belcher Group is an excellently preserved carbonate and siliciclastic package located in the Hudson Bay region. The group is defined by 15 formations, contains no known erosional unconformities, and although is not exposed, is understood to be deposited directly on the Archean basement rock of the Superior Craton. The group was largely deposited during the amalgamation of the Superior and Churchill Cratons during the Trans Hudson orogeny. As such, the entire tectonic and depositional history for the group is connected to the formation of Laurentia during the THO. The Belcher Group represents the western limb of the Circumsuperior Belt, which is a series of correlative Paleoproterozoic basins that surrounds the northern lobe of the Superior Craton formed during the initial rifting phase of the THO. The squished appearance of the islands has been linked to an isoclinal folding event attributed to the Trans Hudson orogeny, and the overall metamorphic grade of the islands and the rocks falls within the prehnite Pompelliite facies. Deposition of the Belcher Group has been broken into 6 main phases of deposition by Ricketts 1979 to represent the variability in depositional environments. Phases 1, 3, and 4 are interpreted to represent deposition along a passive margin during initial rifting, while phases 2 and 5 represent reactivated rift margin volcanism. Phase 6 represents deposition within a foreland basin associated with the collision of the Superior and Churchill Cratons. Precise dating of the group was originally done via potassium archon geochronology in the late 60s, which placed deposition between 1693 and 881 MA. But recent uranium-lead geochronology placed deposition of the oldest Casa-Gaelic formation around 2018 and places the upper constraint of 1854 for the Omarolic formation. Now that we have a bit of an understanding on the background information, I would like to quickly summarize the goal of my project. The primary research objective of this project is to develop a basin analysis for the entire Belcher Group. To do this, I need to first establish a stratigraphic framework to build from by compiling previous work together with my own field research. In doing so, I can hope to understand that the depositional environments were and how they evolved through time. From there, the next step is to take that stratigraphic framework I've compiled and tack on geochemical analyses to bolster my understanding of how the depositional environments relate to the geochemical signatures of the sediments. In addition, establishing a geochemical record for the Belcher Group can allow for later comparison to other coeval sections from across the globe. From there, the next step is to then analyze detrital zircon grains using uranium-lead geochronology and lutetium-hafnium isotopes to elucidate some of the erosional history of the sediment source areas and ultimately address the tectonic setting of the Belcher Group. Now, over the course of the next 10 minutes or so, I'll be discussing some of the lithologies and facies that we see across all of the formations, and kind of the data that we have taken in from the past 2 field seasons of this project. So in the summer of 2018, Camille and I traveled to the Belcher Islands, but due to poor weather, we were restricted to staying in the town of Sanikiluaq. Because of this, we weren't able to see as many of the rocks as we would have liked, but we were still able to measure 6 stratigraphic sections and document 12 of the 15 formations. In the following summer, Zach Pollock and myself were joined by Malcolm Hodgkiss in the Belcher Islands, and due to an earlier start and overall better weather, we were able to establish 4 different camps, in which we were able to measure over 3,400 meters of section across 17 stratigraphic sections. Between the 2018 and 2019 field seasons, all of the Belcher Group formations have been observed and documented. However, due to the sheer number of formations, more time is needed in the islands. That said, over the next couple of minutes, I will discuss some of the highlights of those past field seasons and give a kind of quick overview of those formations. So, due to the island hopping nature of my fieldwork and the fact that we weren't helicopter supported, which is a very big sore point for me, but I will live. We needed the help of locals and their boats to ship us around to our various camp locations. And in reality, this was a pretty cool experience because for the most part, we had to bob and weave between a lot of the sea ice, which, I don't know, a lot of people may get helicopters, but I got icebergs. Now, one of the fallbacks of being on an island in Hudson Bay, especially at this time of year, is the very real possibility of coming across polar bears. Now, fortunately for all of us, Malcolm, the gentleman who joined us, had a small bear fence, so we were able to wrap up our 3 tents all nice and close and at least set a dinner bell for them if anything were to happen. But unlike other northern field research programs, the bugs of the Belcher Islands aren't really that bad. We didn't have to deal with black flies. We just had to deal with, pterodactyl-sized mosquitoes, which really aren't too bad unless you forgot your bug net like Zach did one day, and they will cause a small mental breakdown. Considering all that, relatively, those are small hurdles. The biggest one with working on an island is the weather, and nothing like that can eat up field days. So many of our days were cut short or canceled completely due to either heavy fog blowing in, rain, or anything like that. And we experienced what is quite possibly the most intense storm I have ever been a part of, and lightning and everything. And when you are the tallest thing on an island, it's is extra terrifying. Okay, now I've given you kind of the fun little bits. I'm going to discuss the lithologies of the formations and kind of some of the dominant things that we see. So the lowest most formation here is the Casagalic. It has an unknown base, like I had mentioned before, although it is likely unconformally on Archean basement rock of the Superior. And this is based on some correlative sections that are located in the Richmond Gulf along Quebec. So the dominant lithologies in this formation are broken into 5 subdivisions, representing supertidal to intertidal facies. Divisions A and B are dominated by light gray dolomicrite and reg argillites and contain these halite casts as well as structures indicative of subaerial exposure, which were a really cool thing to come across for the first time, as you can kind of see in that middle left photo there. Now, units C and D are dominantly light gray to pink stromatolitic dolstones that become more complex in structure as you work up section. Unit D, the big difference between it and Unit C is that it exhibits multiple horizons of chert replacement, which have been targeted for microfossils in earlier works by Ricketts and is a focus of what Zach Pollock's master's research is on. Unit E is represented by kind of these pink argillaceous dolstones, but we actually never saw any of those in the field. One thing I would like to note in this slide is that central photo of those kind of laths of silty or dolomicrite, and what we're calling, or what have been noted as these rosettes, and so kind of these interesting little build-up features that you see throughout the Belcher Group. So following that, we have our Eskimo Formation. This is interpreted as a subaerial continental basalt flow of kind of a tholeiitic composition that originated from a western source. This formation is largely composed of massive aphanitic gray-green basalt flows, although you do see intervals of plagioclase phenocrysts, as well as multiple tophaceous layers throughout. So just a couple little glamour shots with that. Personally, the volcanics aren't a big interest of mine, but they are still a part of this program. Following section, this would actually be the one formation that we have seen the least of, and it's the Fairweather. It's interpreted to represent kind of this starting phase of a re-emerging transgressive carbonate platform. As I had mentioned, there's those 6 main depositional phases that had been identified. The Fairweather itself has been broken into a lower and upper unit. This lower unit is dominated mainly by pisolitic dull stones, capped by kind of a thin mudstone veneer. The upper portion, which is characterized by kind of these 18 separate shoaling upward sequences, and each one of those cycles is defined by this like kind of lower member herringbone cross-stratified sandstones, these channel scours, these flazer bedding and all that, kind of that indicate this low energy mixed kind of tidal flat environment, while the upper portion ends up being those largely pisolitic dull stones. And yeah, it's an interesting little unit to see. Unfortunately, we really only ever saw the upper Fairweather, which is more this kind of interplay between mudstone and sandstone lithologies. Yeah. Okay, so the next formation is the McCleary Formation. It is broken into 3, I guess, units, and each unit is based on the overall evolution of stromatolitic features, with the complexity and abundance of those features increasing upwards as you get into the upper McCleary. So the lower McCleary itself is characterized by these repeating cycles of beach rock and or these stone rosette horizons that I mentioned. And these have been interpreted to represent kind of upward shoaling cycles. And then kind of the dominant lithologies are actually, to be honest, rather boring. It's kind of dolomicrite and silty dolomicrite, kind of just a sea of that. So the middle McCleary, it's defined by up to 5 sandstone to kind of these sandy doloarenite cycles. The member contains abundant stone rosettes, just like the lower member did, as well as numerous pisolitic greenstone units, which are kind of visible here in that rightermost image. You can see a little pisolite. Evidence of stromatolitic dullstone is found further up in the section, but that's closer to the contact with the upper member, which is really defined by these kind of micro or mini stromatolites that we refer to, which are shown in that slide with that 18-9 title card there. But as you can see, there's just a couple other evidence of some soft sediment deformation, some trough cross-bedding, as well as some larger kind of lobate to domal stromatolites seen in the left side there. So the upper McCleary, the upper member itself has been broken into 3 zones, like further to 3 divisions by Ricketts in 1979 to reflect that increase in morphological complexation of the stromatolites. The lowest zone is largely composed of dullstone units with kind of with an abundance of microbial laminates and kind of bioherm structures. Kind of in that bottom left-hand corner, you can see. The middle division contains larger domal stromatolites, kind of on the orders of like 2-ish meters, but they're also found to have kind of branching forms closer to the top of those structures. The uppermost division contains conophytons, which are just a really trippy stromatolic form to see. They kind of form a cone shape, and it's quite an interesting little thing. It's a nice little tidbit, as well as branching and non-branching lobate and columnar forms, as well as kind of these digitate stromatolites, which once you've seen 6 weeks worth of them gets a little boring, but the first time you come across them, it's truly are an amazing feature to come across and kind of get to experience. With the kind of increase in complexity of those stromatolic forms, that it's taken as evidence to suggest that this kind of upper McCleary is the first fully subaqueous kind of depositional environment that we're experiencing. Okay, so the following formation, it's the Tukarak, and this is divided into 2 members. The lower part is largely composed of thinly laminated kind of to wavy bedded siltstones. There are some instances of kind of immature sandstones, and you really do get quite a wide range of sedimentary structures that are typically associated with kind of these tidal environments. Now, the upper member itself is characterized by more of a maroon mudstone to kind of buff-colored dolomicrites. There are lenticular and flazer bedding that can be observed, as well as some just kind of more of this like tidal environment, tidal flat structures. So the Maver Formation, kind of the one that caught my eye the most. Just, I guess I don't have a photo of it here, but they are some truly massive reef complexes that you can see from aerial images that show the development of, again, this reef complex, which is quite impressive. But the formation itself, largely dolomicrite and kind of this stromatolic dolostone. The lower portion of the formation, is dominated by these upward shoaling cycles. Said structures present, you see these rosettes, you see a lot of low angle cross bedding, kind of some flazer and lenticular and wavy bedding, a little bit of the cryptalgal outlaminations, which are all kind of taken to take as evidence, I guess, of a subtidal to beach environment. Similar to the McCleary Formation, stromatolite morphologies increase in complexity as you work upsection, and that's again due to that kind of formation of that reef complex that I mentioned at the start. One thing I thought was very interesting, because I hadn't seen one before I had got to the Belchers, was a stylite, which is, you can see in the kind of the top right picture there. Just an interesting little feature to come across. Okay, next formation is the Costello. The Costello Formation is hundreds of meters of rhythmically bedded dolomicrite on top of kind of this small little 50-meter package of dark gray to black shales. The lowermost 100 meters is kind of uninteresting dolomicrite that transitions into kind of this, maroony dolomicrite. But it is kind of a cool thing to see, quite pretty. Bed thicknesses decrease upsection, and then you see a lot of intraformational conglomerates and slump folds closer to the upper portion, which have been taken and are also taken to suggest kind of deposition along a slope. Just that bottom center one is a nice little slump fold, and then some of those conglomerates. One key feature of the Costello Formation, which is discussed in Hodgkiss 2019, are these large barite crystals, which just a very interesting little thing to come across in the field. All right, and then we have the Laddie Formation. Just like basically every formation that exists in the Belchers, it is also split into two members. The lower member is characterized kind of by this red dolomicrite and calcite horizons that you can see in the photo, whereas the upper is broken into kind of more of these tan green mudstones, or kind of green mudstones, which, based on where we had taken or measured our section through, had weathered out quite a bit, and so I have very little or very poor photos of that, so I apologize in that sense. But it was very interesting to come across these kind of calcite nodule horizons, and it acts as a good marker bed for the area. Okay. Following the Laddie, we have the Rowett. Again, it is broken into a lower and upper member. The lower has been broken down further into three zones. Zone A is kind of these largely tabular coarse-grained sandstones, whereas kind of Zone B is more of these interclass conglomerates and dolomitic sandstones with thick intervals of thinly laminated kind of greeny mudstones that you can kind of, I guess you see more of the kind of intraformational conglomerates here in the bottom, in that bottom three photos. One of the interesting things with this section is we were kind of able to take the section that we had measured and really define the zones based on the kind of the earlier works of Ricketts, and so kind of the subdivisions of the section that we had measured through here. Now the upper Rowett is quite a stark contrast to what you see in the lower member. It's quite visually distinct, as you kind of get these kind of, like I said, the gray greenies, whereas the upper unit is these kind of buff orange colored dolomitic grainstones, which is a little bit difficult to take out in that bottom left hand photo, but you do also see kind of these desiccation structures in that upper unit, which were quite interesting to come across and have were a large discussion point while in the field. Okay, following that is what I call by death by quartz. We have the Mukpalo. It's a large formation of mature quartz aeronites. Do find some desiccation cracks kind of earlier on in the section, but a lot of the structures you see are straight crested wave riffles, a lot of trough cross bedding, and what I think is kind of a good visual of it is the channelization, as you can see by the nice big white block beside Zach there in the photo. Okay, following the Mukpalo is probably one of the most interesting units in the Belcher group. It's the Kipaloo, and the Kipaloo is a granular iron formation. It's dominated by these iron-rich argillites and these lenses and nodules of this granular jasper. It's a fairly thin formation, relatively speaking. It's been broken into kind of 6 main lithological zones, with the kind of the lower first 3 are these kind of highly fissile green micrites and red argillites, where the kind of zones, kind of 2 to 4 of these kind of central zones become more of these well-bedded to wavy lenticular bedding, where you see a lot more of the jasper and the actual granules, like you can see in that top right photo, as well as that bottom left, or bottom right, sorry. And then kind of the top 2 zones, we start to transition away from that granular iron formations more into, or back into kind of these thinly bedded laminated red argillites. And I mentioned that this is the most interesting one, because at the very start, when I had said a big feature of the Archean atmosphere was the lack of oxygen and allowing the deposition or the accumulation of that iron 2+ to form, and then the deposition of iron formations, and then those disappearing during the Great Oxidation Event. And then one of kind of a talking point is that why do we see granular iron formations and iron formations pop up after we have the kind of advent of oxygen in the atmosphere? And so to have this in the Belcher group, brings up a lot of questions to work through it and investigate. Okay, following that, we have the Flaherty Formation. Again, not the world's biggest fan of volcanics, but there are some pretty neat features into it. It's also kind of this gray-green of ferric basalt. We do see some pillared flows that vary quite a bit in thickness, but their lateral continuity can be traced for kilometers. You see some kilometer jointing interiors. They also have highly vesicular ropey kind of flow tops, as well as some brecciated flow tops. And then you do see the occasional volcanic breccia and this kind of occasional turbidite sequences in them too. So in here, just that first sequence, kind of more of these turbidite sequences in that top left, a nice like wall of pillowed basalt, and then some breccia, or sorry, not breccia, some tufaceous layers, and some pillow rinds, which I think are a little interesting to look at. Okay, and then we come to our last 2 formations, the Omarolic and Loaf. So the Omarolic is disconformally on top of the Flaherty and interpreted to represent deposition in a foreland basin that formed during the collision of the Superior and Churchill cratons. It, like everything else, appears to be broken into 2 members, but it's dominated by kind of these well-bedded gray wackies and shales, and largely exhibits a variation of Boma sequences and turbidite sequences throughout. Now, interesting factor about this are these kind of little nodules that you see. So quaternary geologists call these omars, and they are a really great tracer for glacial movement. And hopefully at some point we'll be doing a little bit of work with the Manitoba Geological Survey, looking at some of those samples just to kind of characterize some of them a little bit better geochemically, and see if what they're finding in till samples are geochemically the same as what we're seeing in the actual Omarolic samples. So neat little feature about that. And then I don't have any photos of it, unfortunately. And then we have kind of the low formation, which again, broken into two divisions. But it's this dominantly sandstone, conglomerates, and mudstone siltstone facies. See large planar and trough crossbedding desiccation structures and kind of some soft set ball and load structures. But the interesting kind of factor about that is that it's been interpreted to represent this fluvial environment. So it's quite the weird little dynamic that the Belcher Group has got. So we go from this deep, almost basinal turbidite facies environment to having a fluvial environment. So it is a little strange to have identified any unconformities throughout the entire formation. So it's definitely an interesting place to look. With that, I would like to thank everyone for sitting through this and listening to me blabber on and kind of doing a show and tell. Obviously, I'd like to thank Zach and Malcolm for all their help and that. Peter Novalinga was kind of our first boat guy when Camille and I had gone, and then Lisi Mikiuk had helped or gave us a place to stay when things had gone a little different. And then my biggest thanks goes to Gary Rumbold and Daisy Kavik, who've just made all of that 2019 season possible. And then NSTP for all their funding, as well as Camille's NSERC Discovery Grant, and then the Geological Society GSA grant that I received. I appreciate all of that help in that. Thank you.